But today we're going to be looking at implicit differentiation. Okay, now what is implicit differentiation? Well, let me show you by showing you when we do normal differentiation, which is explicit differentiation. So when we do y is equal to x squared, for example, and we differentiate, what do? We do dy over dx, and that's equal to 2x, yeah? So we are differentiating with respect to x. Now, this here is the differentiation of y, okay? And this here is the differentiation of x. What we are going to be looking at today is examples when you have x's and y's to differentiate, okay? So I'll show you through several different examples. So if it was y equals x squared plus 3x, then you do your normal differentiation. But this one is y squared plus x squared equals, 8x. So imagine you are differentiating this now, okay? That's what we are going to be looking at. So two things I want you to write down. For implicit differentiation, you need to know those two things. Differentiate each side of the equation using the chain rule if necessary. And remember that y differentiated with respect to x is by definition dy over dx. So have a look here. We want to differentiate these examples, and after these examples I'll show you a few more. All right, so have a look at the first one. So I want to differentiate y squared with respect to x. So the differentiation of y squared with respect to x. What's it going to be? Yeah. So usually what do? We have y is equal to x squared something, 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 yeah? But now we have y squared. So we want to differentiate y squared. So we do everything as normal, which is we are going to use the chain rule here. Just a quick reminder of what the chain rule is. So for example, if you have x squared plus 3x squared, for example, and you do the dy and dx of this one, what do? You drop the power down. What do you get? 2, and then you get x squared plus 3x, and you take 1 away from the power, right, giving you 1, and then you differentiate what's inside the bracket, right? So what's inside the bracket to differentiate? 2x. Oops, 2x plus 3, okay? And then that's your chain rule, okay? And then you can simplify this or if you wanted to, okay? So the same process we are going to apply here. So it's like y squared. So we are going to do the differentiation of that. So the 2 drops down. What do you get? 2y, and you take 1 away from the power, okay? And then you differentiate the y itself, what's inside the bracket, yeah? Just like you differentiate what's in here. So what did we see earlier? When you differentiate y, the differentiation of y is dy over dx. So you just write dy over dx. Okay, let's do another example. So for this one, we are going to differentiate sine y with respect to x. So how do you do it? What's the differentiation of sine? Cos. So the differentiation of sine is cos y. Yeah? Now, just imagine the bracket around the y. The bracket being here or the bracket being here, and now we are going to differentiate just the bracket. Okay? So what's the differentiation of just y? And we just write dy over dx. And that is this differentiated implicitly. All right, I'm just going to get rid of this. So let's have a look at this one now. So we want to differentiate e to the y. Just a quick reminder, to differentiate e to the y with respect to x, just go back to how we normally differentiate e. So if we have something like e to the x cubed, how do we differentiate this? We do dy over dx is equal to, we differentiate that, bring it to the front, right? So what do we get for that one? 3x squared, yeah? And then we write e to the x cubed. That's what we normally do, right? Let's have a look at this one. We differentiate the y. What do you get when you differentiate the y? Dy over dx. And then you write e to the y. That's it. But you might want to write this as e to the y dy over dx. Just a nice form of it. Let's have a look at the next one. So what do we have here? We have two things which are multiplying with each other, right? So what we are going to be applying is the product rule. We are going to be using the product rule. So when we have u as x, and we have v as y. So the differentiation of u is 1. The differentiation of v is dy over dx. You could write a 1 dy over dx, because just like you wrote 1 for this one, you could write a 1 here, but because we're going to be writing dy over dx, and in algebra we don't use that 1, we can just write dy over dx, yeah? And then you put the product rule together. So it's this times by that plus this times by that, yeah? So the differentiation of this, so the differentiation of xy with respect to x is going to be this product rule put together. So go ahead, it's going to be x times that. So x times dy over dx plus y times 1. And we can just write y. And that's this differentiated. So have a look at these ones now. We want to differentiate tan x plus y. So what is the, in fact, so let's just write d, differentiation of that with respect to x, yeah? So what's the differentiation of tan? Sec squared x plus y, because the bracket is x plus y, yeah? And now we're going to go inside the bracket using the chain rule, and we're going to differentiate what's inside the bracket, yeah? So what's inside the bracket? 1 plus dy over dx. And there you have it. Let's go to this one now. So we're going to differentiate this with respect to x. All right? So we've got two things here. So go ahead. What do we get from here? We get 2x. What do you get when you differentiate cos? Minus sine and sine y. And now we're going to go inside the bracket. That's our thing to go in for, when we do the chain rule. So what's the differentiation of y? Dy over dx. Okay, and then you've got that. So have a look at this one. It says find dy over dx in terms of x and y, where x cubed plus x plus y cubed plus 3y is equal to 6. We are going to differentiate all of that. Okay, now you know what happens when we differentiate y? We have that dy over dx. So let's go. Let's differentiate that. What's the first thing that we get? 3x squared plus 1 plus 3y squared, and now we differentiated the y, didn't we? So what do we write? Dy over dx. That's looking at the bracket. Remember what we were doing? We were looking at the bracket. Continue, plus 3y. What's that differentiated now? So we write 3, and then we look at the bracket. So the bracket is a y, so we write dy over dx. Equal to, what do we do when we have a number? 0. We write a 0. So this is what we have. Right? Now, the question says find dy over dx in terms of x and y. So we want to make dy over dx the subject. We've got it here, we've got it here. All right? So what we can do is take this over to this side, factorize out the dy over dx, and then we'll have a bracket which we'll take to the other side. Yeah? So what does that look like? Let's factorize out the dy over dx first. So just this would become 3y squared plus 3. And on the other side, we're going to take all of this over to the other side. So this will become a negative. So minus 3x squared and minus 1. Right? And our final step would be to do dy over dx is equal to this divided by that. So minus 3x squared minus 1 over 3y squared plus 3. And there we have expressed dy over dx in terms of x and y. So one of you just asked me, you said that the question said 6, but I had a 0 here, yeah? So just to clarify where we got that 0 from, if we were differentiating this whole thing at this stage, and when we differentiated 6, we got 0, because just to give you a quick reminder, if you were to have 3x squared plus, let's say, plus 5, and then I said differentiate this, you do dy over dx, you get, what do you get for this one? You get 6x. And then what do we do with the number? It's plus 0, which we don't normally write. But here we had to write something because we had an equation and we can't just keep it blank. All right, next question. It says find the value of dy over dx at the point 1, 1, where e to the 2x ln y is equal to x plus y minus 2. Okay? And the coordinate point is that. So we want to find dy over dx of this one. So the first thing we're going to do is to differentiate. Okay? We're going to differentiate this side and we are going to differentiate that side. Now on this side, what do we have? We have a product. Okay? And we're going to deal with this product. So u is going to be e to the 2x. V is going to be ln y. So let's deal with that. So u is 2e to x. V is 1 over y. And then we're differentiating the y. So therefore, dy over dx. Is that good? Right. So we're now ready to apply the product rule. So therefore, the differentiation of this side is going to be that and that multiplied plus that and that multiplied. Yeah? So what do we get from this and this? We can write this e to the 2x times by 1 over y dy over dx. Yeah? Plus this and that. So 2e to x ln y. So what we've got here is the differentiation of that. So now we can just write equals and continue the differentiation, right? So what do we get when we differentiate this? 1. What do we get when we differentiate that? Dy over dx. And what did we just say about the numbers? It's 0. Okay, it's not there. So this is that differentiated. Now, we need to express it in dy over dx. So we need to get the dy over dx onto one side, factorize it out as we did previously, and this time we would substitute some values in to find the actual gradient. You good? Right, let's go. So let's simplify a little bit here. So here, what we can do is e to the 2x over y, dy over dx. Just makes our life a lot easier. And what we'll do as well as simplifying is let's bring that dy over dx to this side as well. So here, it will be what? Minus dy over dx. And let's bring everything else over to the other side. So 1 is already there. So it's going to be 1 minus 2e to x ln y. Okay? Then we factorize out the dy over dx. So dy over dx, bracket opens. So we want to expand to give us this. So therefore this will be e to the 2x over y minus 1 is equal to 1 minus 2e 2x ln y. And of course the final step is to make this in the form where dy over dx is the subject. So therefore we're going to divide all of this over to this side. So we're going to have 1 minus 2e 2x ln y over e to the 2x over y minus 1. And now we have dy over dx. So now the question says find the value of dy over dx at this coordinate point. So what will I do? I will substitute the x value and the y value wherever I see an x and a y in my dy over dx, yeah? So let's do that. So sub 1, 1 into this equation. So dy over dx will be equal to 1 minus 2 times e to the power of 2 times 1, because x is 1, right? And then ln 1 all over e to the power of 2 times 1 over y, which is 1, minus 1. So that's my substitution done. The next step is I just start working things out. Now I can see a lot of you reaching for your calculators. Don't bother, right? What does ln 1 equal? 0. ln 1 is equal to 0. So this is 0 multiplying the entire thing here, which also gives us 0. So therefore what's left? 1 is just left. So therefore 1 over, now what's happening here? E, 2 times 1 is 2. So we have e squared. E squared over 1 is just e squared minus 1. So this is your final answer. That is the value of dy over dx at the point 1, 1. Right, so what you've just seen with those examples is an introduction to implicit differentiation. You now need to practice this on exam questions. So next we are going to practice it on 2 more questions which are from past exam papers, the old legacy papers. So that's what we're going to be doing after that, okay?